How do you find the degree of a polynomial with negative exponents? Imagine you're working with a math expression, and suddenly you see some negative numbers as exponents. You might wonder if you can still find the highest power or degree of that expression. Well, the answer is a bit tricky because it depends on what kind of expression you're dealing with. In algebra, a polynomial is made up of terms where variables are raised only to non-negative whole number powers. That means exponents like 0, 1, 2, 3, and so on. When you see something like 3 times squared plus 2 times x plus 1, you can easily find the degree by looking at the highest exponent, which is 2 in this case. But if you come across terms with negative exponents, like x to the power of -1 or x to the power of -3, things change. These terms are not part of a polynomial because they have negative exponents. Instead, they are called rational expressions or Laurent polynomials. They involve variables in the denominator, like 1 over or 1 over x cubed. Since polynomials can't have negative exponents, you can't find a degree for an expression with negative exponents in the usual way. The degree is always the highest non-negative exponent in a polynomial. If your expression has negative exponents, it is not a polynomial, so the idea of degree doesn't really apply. However, if you want to analyze such an expression, you can rewrite it as a rational function. For example, if you have an expression like 2 over x plus 3, you can think of it as a ratio of two polynomials. 0 over 1 and 1 over x then, you can look at the numerator and denominator separately to find their degrees. But remember, this is outside the standard polynomial framework. So, to sum it up, if you want to find the degree of a polynomial, all the exponents must be non-negative whole numbers. If you see negative exponents, the expression isn't a polynomial, and you can't find its degree in the usual sense. Instead, you can analyze it as a rational function by rewriting it with positive exponents in the denominator. This helps clarify the structure but doesn't give you a polynomial degree. Understanding this is important because it helps you identify whether an expression is a polynomial or not. When working on polynomial operations and factoring, knowing whether negative exponents are involved ensures you use the right methods. If negative exponents are present, you'll need to treat the expression differently, focusing on rational functions rather than polynomial degrees.